we had 1,242 people doing the exam, and that's from the South Australian Northern Territory and the International SACE. The results showed us nearly a normal distribution, which was in a better sense than the positively skews that we normally see with the lump at the lower end. So in that respect, it was better. The mean was over 50% for the whole paper. Unfortunately, once we get the internationals and the countries included in our statistics, it does bring the mean down, unfortunately. So before we start marking those, we're thinking, oh, this is all right, and then wham. So there's certainly a need for extra help at the international level and the country regions, which is what leads me to help out the Maths Association as much as I can. Also, just want to point you to, of course, the examiner's comments on the SACE website. There's comments about moderation, about SATs, about folio tasks, and also about the exam. Really detailed, and the markers feed in their comments that they've noticed whilst they've been marking. And so it's as detailed as it can be and as blunt as it can be without the SACE board changing the words. So nobody laughed. Okay, fine. All right, let's get into it. Question 1, I will go through 1, 2 and 3. Then we'll have Val, and then we'll have Dennis, and then we start cycling about. The first question had a mean of 46%, and quite a large number of students who attempted the question achieved 2 marks. And that was mostly from Part A and B Part 1. So you can see in Part A, the 1 mark. Now, we used to assign 2 marks for this, but we are assuming that students can use their graphics calculator to just give the answer straight away there. Part B was really poorly, Part B, Part 1 was okay. They could just substitute in the moduli symbols and either work out the modulus of -1 plus I root 3, or they could have used the polar form from the Part A.
So, excuse me, Deb, if the question says using Part A, but if they didn't, so it's really okay.
Well, we gave that because Part A does actually say -1 plus I root 3. So a bit ambiguous there, so we could have accepted that as well. Sorry? No, okay. So that was 1 mark there. So those 2 marks, the Part A and that B Part 1, were generally very well done. Marking on the Argan diagram, so just a comment with that, we're seeing very sloppy drawing, and we really need to make sure that there is representation of the change in length and the change in argument. So that really does have to show up on their diagram. We're pretty lenient with the marks, and if you've ever been a marker for the exam, you'll know that we are very forgiving, but you shouldn't be in your SAT marking. You should be setting standards such that well, I'll get 3 marks for that no matter what anyway, so I'll just do flip, flip. But please, to help the process, we hope that the school marking is showing better practice for the students. In Part C, we were looking for the triangle inequality as it says to. We often saw the best solutions for that answer there was for students to draw a diagram. You didn't need to, but I'm saying the best solutions we saw, the most easily recognisable correctness was with a diagram there. The step that we were looking for, crucial step there, is the 4th line that Val's, can you see her hovering over that? that was the crucial step we were looking for there, along with some recognition of the triangle inequality with the diagram. It could have been with the diagram, or it could have just been a statement with the Z1, the line above, the one that Val was on. Okay, question 2. The best question out of the whole paper, best achievements, 71% for the mean for that question. The majority of students did gain full marks for that. So we're looking for the marks acknowledging that we've got the product rule and some sort of rearrangement to hopefully get the show that there. A very easy mark in B part 1, honestly, very, very easy. And then in B part 2, again, we've got that requirement for exact, and some students are missing that, even though it's in bold, italic. Again, something that needs to be practiced and pushed in the school assessment. Some people mucked up their substitutions, put in the wrong bits in the wrong places, and therefore lost some marks through that process. Units weren't expected there. Okay, question 3 was the induction. So, as usual, with the examiner's comments, you'll see that what is expected for a induction set out, a proof set out in this style, we need the proposition stated, and the marks go, the line where let P of n equals, or let P of n be, I should say, and the statement since P of 1 blah, 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 those two are awarded 1 mark together. You can't get a mark for the last statement if your maths in between doesn't make sense, even if you have written P of n and that last statement. Yep?
For P of n, can you circle or put a box around in the question everything from A of n to the right and above it right, Pn is that?
Seems a bit lazy, but yes.
Well, we're short on time on these things.
Testing for proposition 1 in this case, so the proposition has to be tested for the first integer that you're able to use, so that's the 1 mark there. There's a mark for the assumption line. There is a mark for the inductive step. So that's really very, very important, seeing that inductive step there. And lastly, playing around with that to get your final right-hand side of PK plus 1. The last part is playing around with that inductive proof. So getting that n was 2018 was what was required there. Somewhere or other, getting 2018 for n was required. So that question, did I say, had a mean of 66%. It's the second most successfully done question throughout the whole paper. So that's questions 1, 2 and 3. Handing over to Val.
Okay, now the first bit asks them to do a... So I'm blind. Ask them to use a division process, and some students didn't technically use a division process. So, I mean, the most obvious one is doing that. I guess you could do synthetic division with x plus I and x take I, but you probably won't. So most of them have done that. If they did try to manipulate it a bit differently, working with the right-hand side a bit, it looked, in most cases, very fudged. When it says a division process, I guess when you look at the curriculum statement, it talks about the synthetic division, long division, etc. So that should be pretty clear to them. Now, when you do this graphing, because it said clearly show the behaviour of the function near any asymptotes, it's very difficult to do behaviour near something if you don't draw that something. So it's kind of an assumption that you would need to draw in the asymptote in order to show, because you can see from the graph it's above on the left-hand side and it's below on the right-hand side. And they needed to be considering the asymptote and also the connection with part A, where they had done the division, and even if they couldn't do that division, the result was given to them, so they could see that the asymptote was going to be y equals x. So I guess if students aren't seeing that, when you do your exam revision, you're going to point out the connection between parts. So definitely, even if it doesn't say put in asymptotes, the wording implies that you're going to need to really justify that your diagram is correct. And going into the next bit, this part was done really well. There were very few who did not get that correct, the composition of functions. Then in D part 1, hang on. No, it's okay. I think this is, you know, in specialist maths and methods, when they apply, you know, an algorithm like the integral of, well, they have pi, the integral of y squared dx, that doesn't allow them to get marks. I mean, I know in general maths I think it might do sometimes, but with us it always has to be in context. So they need to be saying what that y is and showing it squared. And that's essentially what was needed. So just be careful of kids that, you know, just sort of keep it simple without showing the specific substitutions. And a bit like in Deb's question with the related rates, sometimes they just write the formula and don't actually show the substitutions, which is more important. So same idea. And in the last part, it says to show that, the exact volume, again, exact. And most of them who did this did, you know, like if they could get that far, they would do this part all right. And they had it set up for them in part A to work within that. So provided they set up the thing correctly, should have come out all right. Have I got all? Yeah.
You might mention the arctan 1 and arctan 1.
Oh, that's the point, yeah. A lot of them with the 1 on x squared over 1, we saw ln x squared plus 1 when they integrated. So they weren't picking up the arctan. They did the other part, the substitution in the middle part there correctly, but then messed up that end part.
And actually evaluate that.
Yes, they need to show that they have evaluated that arctan 1 is pi, or negative 1 is negative pi on 4. And that's a general thing. Sometimes when they calculate slopes and they just put in like cosine 3 but don't show what it is, same sort of idea. They need to show what those actually are. So that's question 4. Get this all back because I'm shifting sideways. No. Okay, question 5. Oh, by the way, have I got the right paper? Yep. The median for that question 4 was 61%. So it's not too bad. That gave it a ranking of about almost equal third, best question. Then we get to question 5. That also wasn't too bad. Kids usually like matrices. So the first part was fine. Write it as an augmented matrix. I don't think there are any issues there. But when they do the next bit, when it says using clearly stated row operations, can we please make sure they state the row operations? Because we still get students who don't, and they need to. And it may not be exactly as what I've presented here, but we obviously check through what they've done. So clearly state them. And I think that in that second, that bit where you've got row 2 take row 3, they should be, if the algebra is a little bit more complex, it's not enough to just whack in, this is the row operation. There should be some justification for the results that we're asking show that it gets to that result. So there should be some working, not just saying, oh, this is the row operation. So that's why I've got the little bit down the bottom there. And in the next part, they need to use a highlighter and read it carefully. State a value of m for which there is a unique solution. There was an awful lot of m is not equal to plus or minus 2, not equal to 0. We just needed a correct value for m. So anything m equals 1 is just one example. So I guess that's attention to detail. Read the question, highlight it, make sure you've answered exactly what it said. It didn't ask what it couldn't be. It asked what it could be. And the last bit, this has been in other exams, so they should be pretty familiar. And it had just 1 mark, so essentially it's just figure D. If they just wrote figure D, they'll get it, but I've put in a bit of justification. No solutions when you look at that last row when you use m equals -2, and as none of the planes were parallel, it had to be figure D. So now I pass over to Dennis.
Greetings, everyone. Welcome to something that it always gives me a lot of deja vu. I always get the middle game. The middle game in chess is very important. The middle game in specialist maths, which is very much like a game of chess. You have your opening gambits. You hopefully do well. You hopefully gather the marks whilst you may. Questions 1 to 5. A little bit of a hiccup with the complex number question, really quite tragic. But questions 6, 7 and 8, they sort of make your future. If you do well in 6, 7 and 8, the professions of law and medicine await you. If you don't do so well, maybe teaching. If you do really poorly and you can't get a maths degree, it's administration for you. You know what happens in that. Question 6, a real body crusher. A nice friendly question on integration by parts and graphing. And who shouldn't be able to pick up some marks by using their graphic calculator and plugging in a few values? Question 6 was a shocker. About 15% of the kids couldn't even pick up a mark for that. It was the worst handled question in paper 1. It had a mean score of about 40%. And without getting too dramatic, the 4 horsemen of the apocalypse come riding by for the kids. Those horsemen were show all working, didn't happen. Label your graphs, didn't happen. Watch your domain, didn't happen. And draw a nice friendly graph to explain. That question 6 was really very sad, and we had a similar question last year, unfortunately. Integration by parts is pretty trendy. It shows that we've got a very mature course. 8 years ago, we didn't have integration by parts. It was deemed too difficult for a Year 12 course in South Australia. Of course, every other state in Australia had integration by parts, but we brought it on board. You've got to have the right choice for V' and U. If you make the wrong choice, maybe you start again. But we had a very clear statement, show all the working. And of course, we give them the answers so they can pursue the question. So you think, oh, we're doing them a favour, but alas, we really don't. Most good students missed out on the mark, the second line of having -1/2 outside the integral sign, -2x, 1 take x squared to the power of -1/2 with respect to x. They missed that step. Some of them were obviously champions and could do it in their heads. Some of them were maybe villains. These are the ones who'll get into admin, so you'd better be careful what you say. And they just saw the answer there and they put the answer down. But too many only got 1 mark out of 2 for something that was kind of straightforward. Okay, so that was really quite sad. we had a nice graph to be drawn. Okay, you had to be a little bit careful that you had the shape, and it looked quite good. And I guess we love arrows, but we had a restricted domain. And if the students went further than 1 and less than -1, they lost a mark. How tragic. Okay, domain we sort of teach somewhere in the younger years. So for a gift of 2 marks, and that was the kind of intention, let's get them along their way. They only got 1 out of 2. And then the biggest tragedy is we asked them to sketch the graph of the modulus of f of x, and we asked to have it on the same graph. So the students had to identify which was which, and a lot of them made too large a call on the markers. They wanted the markers to do the thinking for them. And if the students didn't label the graph, they lost a mark. Okay, kind of tragic, and you'd think the kids would know what was going on. Okay, so there was another mark lost, sadly. As we go up, kind of an easy mark. We were looking for a nice shape. We just didn't want an inverted parabola, but we were kind of generous. And just to show that there is a heart in these 2 ladies, if they put arrows on in the second case, it was actually me who fought really hard not to take off another mark. Okay, so if they put arrows on the second graph, they didn't lose the mark again because they were penalised in the first. And sorry, I do jest. The marking procedure is outstanding because of these 2, not me. I'm saying let's hit the kids who don't go to a nice state school, but they say let's be fair to everyone. Okay, and further on, part C, a monster question, really quite difficult. You had to find that green shaded area. So I guess a diagram would have been wonderful. But so many students got 0 marks out of 4 because they didn't worry about the diagram, they didn't worry about the question, and there is joy in ignorance, but unfortunately you don't pick any marks. And they really didn't find that area by saying it's all this little rectangle of pi on 2, take 1, subtract that other bit, which we've found the modulus of that. And that yada, yada, yada was a good lot of work. But one of the beauties of doing these exams is that people who think they are quite wise and they think they've got wonderful solutions, there were some outstanding kids who'll most probably end up as teachers. There were some outstanding kids who just said it was the higher function, which was this one here, subtract the lower function, which was y equals -pi on 2, and they did their bit, and all they had to do was find the integral of arc cosine x between 0 and 1. I mean, really lovely. And for us who mark the paper late at night, it's good to see that type of thing. So there were some nice solutions, but unfortunately in the 1,242 candidates who did the paper, as I said, about 150 got no marks and only about 50 got full marks for that question. And it wasn't intended to be demonic, but it was just sort of an example of what we should get to our kids and say, what's your domain? Make sure you label different graphs. Make sure you show all your working. And if a kid tells you, I'm too cool to show all my working, I'm too smart to show all my working, your kind of retort, or our general retort is, if you're so smart, you'll follow what they tell you to do. So that was question 6, and that was really quite sad. But in most years, and I've been giving this middle game, it's always that question 6 or question 7 that crunches them where they shouldn't be crunched. Question 7, they love logistic. They even put it on their reference sheet, and most times they use it properly. And the slope fields, most of us are good drivers. We can stick in between the lines, so the slope field looks quite good. This question was really well done. It had a mean mark in the mid 60%, which is really quite good. It was beautiful to see that there were only maybe about 30 kids out of the 1,200 who didn't want to take up the question and didn't even score a mark. And it is quite tragic that in something that's a reasonable question that someone can't even pick up a mark. That's sort of kind of a sadness and shows a little bit of a wasted year. That very first part, we used to get answers like, hey, this must be correct because it's on our formula sheet, but now we actually give them to show that little bit of algebra. And that's kind of, I mean, logistic DEs are in mostly, say, 3 exams out of 4. Everyone is picking up that. Solving the differential equation, there was a little bit of an algebraic twist at the end, which maybe caught 1 or 2 kids out, but they're really good at separating the variables. We love them. We just sit in awe when they get the integral of 1 over y. They get ln mod y, which isn't in the methods reference sheet. But of course, the methods, in fairness to them, they only consider y to be a positive, so they don't have to play around with that. But we can have y as negative, and we've sort of said, oh, it's got to be ln mod y, yada, 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 u. But that question was really well done, the differential equation, and that is really high-powered mathematics. I mean, once again, we didn't do that 10 years ago. If you can see a kid do that, do a separable differential equation, they really are going somewhere. Not admin. Anyway, who said that? Part 2, I know I can be a little bit of a smart aleck in saying, oh, why don't you read the question? I guess they don't read the question because they are in a rush. And we do have 10 minutes reading time, but we actually embed that reading time as let's get our biro and let's start writing. The question said they're fine to the nearest whole number, and we didn't mind if you rounded up or rounded down. But a lot of good students, once again, forfeited 1 mark. They didn't lose it, they forfeited 1 mark because they didn't write it to the nearest integer, they wrote it to 3 significant figures. Why would they do that? Because they're kind of good kids and they expect things to be 3 significant figures. But for here, for some reason, for the 2 marks, they had to give it to the nearest integer. And as we said, could have been 2415, 2416, they could have rounded up or round down, but they had to do it to the nearest integer. So kids lost that. And then the very final bit, boy, kids love this. I mean, if ever you got a last lesson of the day on Friday and the kids don't want to do stuff, give them a slope field and let their hearts go wild. 3 nice marks. You got to start at 20,000 0. You got to asymptotically approach the bottom. Where could you muck up? Well, we actually gave them the point 50, 5,000. That should have been part of your little roadmap. So you should have run over the poor, sorry, I shouldn't say policeman, but whoever's at 55,000, that point you have to go through. Okay, so that mark was lost by a few, but question 7, once again, was really well done. Paper 1, it had a glitch in question 1, which was sad to start off in question 1, and question 6 shouldn't have been a glitch, and that's something to communicate to our kids. You know, watch out, especially if there's more than 1 graph. That's just a tragedy. You lose a mark for not labelling it. And then paper 2, heaven. Heaven is seeing a vector. Okay, we love vectors. Vectors are everywhere. It's a favourite. It's like grandma's homemade cooking. It's like, you know, the Crows. Remember when the Crows used to win a game of football? You used to turn on TV on Saturday and they would win. It was like the good old days. It's vectors, it's cross product, it's planes, it's lines, it's dot products. Maybe there's a little sting in the tail at the end, but vectors is always quite friendly. And I've got to say that over the last 10 years, from kids not knowing the difference between a plane and a line and all this stuff, kids are particularly good at vectors. They are a little bit lazy and they kind of don't give all the reasons, and we're kind of generous in what happens. I'll show you what I mean. In A part 1, for 2 marks, a vector cross product, that's a nice sweetie. That's nice 2 easy marks for the student. And then they really test the generosity of their markers, hence show that the equation of the plane is x add y add z equals 1. If you're kind of lucky, and we should be maybe more demanding, they will give you the direction numbers. Oh, the cross product gives me the direction numbers of the normal. A lot of students don't want to say that. They might say, here's 1, 1, 1, but they don't tell us why. They really should tell us why. And they use a point and they don't tell us what the point is. So there is a real danger that a lot of students will not get the 2 marks out of 2, even though they know what they're doing, but they're not showing all their working. If we didn't give them an answer, then we would accept x at y at z equals 1, but we kind of like them to have the answers so they can pursue further parts of the question. So it's us trying to be generous. It maybe causes a little bit of problem. B part 1 was nicely well done. Show that something is a diameter, and there were several ways of doing it. You could have used the midpoint to find it. You could have shown that the vector AC is equal to the vector AD. And some of them, bless them, they must have been teachers in disguise. They actually used geometry. They actually used that the angle in a semicircle is a right angle and shown that those vectors AC and, the BA and BD were equal to 0, and that thing must have been a diameter. There's some really nice proofs in that. Okay, but that was just 1 mark, but kids are going well, finding the radius. They were really cooking. They picked up that 1 mark. I guess they were feeling happy. Life is great. Vectors is great. I keep saying vectors is great because they are. And then again, maybe they're a little bit trusting. They want you to show that the equation of the line was that in parametric form. Once again, they were given the equation of the line because they had to use it in the next part of the question. Just about everyone said EB is equal to -3, 1, 2. They got that vector, but they kind of didn't say where the 8, -4, -3 came from. They just put it down there. Maybe it's a little bit tedious, but they should have said, hey, I'm using the point E on the line. And I would certainly hope that we would direct our students to do that. But they do become casual. I know they're in a rush and everything like that, but they've really got to defend their actions. Otherwise, they lose a mark, which should be an easy mark, because storm clouds are coming. Part D, a really nice question, but once again, it actually buoyed our hearts to see most students did particularly well in that. They plugged in the parametric equation of the line into the equation of the circle. They got a couple of values, 15/7 and 1, and they dismissed 1 and they used the 15/7. A few just stopped there and just said, oh, hey, therefore the point must be 11/7, -13/7, 9/7. They really had to show us the line, x equals 8, subtract 3 lots of 15/7. They actually had to show that little bit of working, not just assume it. But that was particularly well done. We were all very impressed the way kids did in that part of the question. And then the end, as you would expect in a vector question, is a little bit difficult. They had to find the arc length of BX. A few kids with a little bit of gumption, they just wanted to give the length of BX, not the arc length of that. They just gave the length of the line, and even some used the parametric form and found the arc length from the parametric form. It didn't get them anywhere. They had to actually find the angle theta, which was the angle XCB. They've got the radius, and they do a little bit of work, and that 3 marks at the end, that was for the very, very good students. As there were quite a few, the mean score for that was over 60%, and that's great for paper 2, because what you're going to hear from the ladies is over 50% doesn't get touched again for the other 2 questions. Beautiful in the vectors, only about 20 kids didn't score any marks. So someone had an idea about cross products. So the time we spend on vectors is not a total loss. And those that got full marks, there were about 100 kids who got full marks for that question. So there were some very good candidates. But things are kind of set up. What happens in the end is determined by question 9 and 10. And Valerie will tell you about the journey in question 9.
Okay, we've got the path of a comet. And they've given the parametric equations and asked to draw it on the axes there. And as you can see from the graph, they're wouldn't probably be arrows on the end of that. It's not defined at pi on 2 and 3 pi on 2. So they could have used trace and got points to draw in the shape of it. So, and by the way, yeah, the median score for this, or mean score, was 44%. But Deb has to deal with the last one, so that gets even... yeah, no worries. Well, he started it. So, at what time is the comet closest to the planet, which we've marked at P there? And clearly it's at that spot there that's marked, and it turns out to be pi. And then it simply says on the axes in figure 9, mark as point A, the position. That was pretty well done by most kids because that part was easy. And then we...
Arrowheads on the end of the graph, because they didn't do it in the first booklet, would they have got penalised in the second booklet?
I don't think we did. No. All right. And then B part 1, show that dy dx. I was looking at this before. I think I've written y dash t over x dash t because the answer is given, and it's good to say that what you're doing is dy dt over dx dt, or they somewhere else write, here's dy dt, here's dx dt, and then they've got one over the other, because there are 3 marks that are assigned there, and you're probably thinking, well, dy dt is 1 mark, dx dt is another mark. So it's important that they explain that they are doing dy dt over dx dt. And then the next part, it's a give me mark, because they're doing 5 pi on 6 and they've got the expression in B part 1, so they just put it in and they work it out, and it comes to root 3, was it? And then the next part said on the axes in figure 9, show that result. So when you go back to the graph, you've got to draw in that, I've written B part 3 next to it, a little arrow. The position should be about correct where it's starting, which is, you can kind of see where it touches there. We're fairly generous, but they need to indicate that that slope is about root 3. And next bit, show that the speed is given by that expression. I think a lot of students were fine with the x dash squared, and again, they need to put it into context. So they've got 2 sine t on cos squared t all squared plus the next bit. That's showing the concept that they're applying. And then it's about them. It wasn't a very difficult one to expand, but they had to do that. I guess what they needed to show was that because you had cos squared on the denominator and it was squared, how that came out of the root sign, because otherwise it just looked like it magically, because the answer was given. If they didn't explain that part of it, they could have lost a mark. And then it said, hence find the distance travelled between those limits there. And so generally speaking, that you would do to 3 significant figures, but there was no penalty if it wasn't done exactly like that, because they had to get the expression and then calculate it. And it didn't state accuracy. So as you know, the default is 3 significant figures, and it is written on the front of the exam paper that the default is 3 significant figures. So now I'll pass on to Deb for the best one.
Okay, the monster one. The mean score for this was unfortunately 36%. A lot of students recorded 0, and then the next highest was about 3. So obviously a struggle here. So in the first part, we're looking for state the roots of the, roots of the complex equation. So we were looking for that set of solutions. Now, if they did write over on to the right there, cis 5 pi on 3 and cis 4 pi on 3, that was fine. We did need it in r cis theta form, so writing in Cartesian was not appropriate. We are fairly generous when we give marks for this. If the students wrote cis k 2 pi on 6 for k is equal to 0, you would have got full marks for that.
There could be witnesses that only there was one Z2, Z4, where Z equals 6 pi on 3.
With yes, yeah.
Sorry, what if they just wrote 1 rather than 1 cis 0?
That was okay. Yep. I mean, we're not, yeah. 1 cis 0, we would have accepted 1, yeah, for sure.
Will you generally take the argument up to 2 pi, just in general? Just like you did there, is that sort of general marking thing, it's fine as long as it's under 2 pi? Or do you sometimes require it to be between negative pi and pi?
Well, we're saying that we would accept both.
And that's in general, not just on this problem?
Correct.
Thank you.
Unless it's stated in the question otherwise, presumably.
Yeah, it should actually be pi to negative pi, but and you know, like I've been saying for every single thing that I've gone through tonight, it's your place and our place when we're teaching to actually teach the correct, and we're more gracious in our marking for exams because they do have that time, the rush, that sort of thing. So we try to work for them, not against them. Now, again, the Argan diagram, I mentioned this before in a previous question, the drawings can be rather sloppy. So we've got to look for the positioning of the angles for the complex numbers. They can be rays or they can be points. We weren't concerned about either points or rays from the origin. But we do have to have an indication of length being the same for every complex number. Whether you put a circle around the solution like Val has here or not, you could just label one of them mod Z equals and then indicate the same length with the little dashes for side lengths. But we do need that radius being equal acknowledged, as well as I said, positioning around the circle correctly or positioning around the Argan plane correctly. The part B, part 1, they could have, this is a nice solution, or we could have had it in Cartesian form. Either one of those would have been okay. They could have used their calculator to solve Z take 1 to 6 take 1 equals 0 or equals 1, whichever way you want to do it on your calculator. You could have done that to get the 2 marks. You could have, quite correctly, the solutions that you would have found in B part 2, you could have put there as well. So as markers, we had to be quite alert to all of that, but they just basically somewhere in there, they had to do one of those 3. B part 2, we needed the solutions written that way. Again, we don't need the dashed circle. We can just have an indication of side lengths being correctly equal for each solution.
Sorry, question on that.
Yep.
Is it okay if all the vectors there were instead drawn from the origin to the end?
If they represented the correct solution.
So the circle's there, but every arrow goes from the origin.
Yes, that did get full marks. Yeah, thanks for pointing that out. I forgot to mention that. Thank you. In part 3, again, calculator could be used there, as I mentioned before. We do need them in polar form, or it says they're real form, so that was for the solutions 0 and 2. In C part 1, a lot of students did not... Oh, hang on. What have you got there? Yep. A lot of students didn't use the real polynomial, therefore the conjugate, etc., etc. What was more commonly used was the sum and product of roots. approach. Either one, doesn't matter, as long as, and again, this was an area where students were not very good at explaining their processes. They could have been more clear in their working. But again, we were very generous for those 2 marks. And the verification, lots of different ways students could have done this verification. Just as a heads up, when students chose to use the Pascal's triangle, we really did need to see that -1 in the expansion raised to a particular power. Otherwise, they were just writing down the show that. There was lots of different ways of doing that. Part D was the connecting of all the bits and pieces from previous parts of the question. So the recognition of that got students through to the final part there, using the sum and products again, using part C where Val's little hand is, and also in the next bracket as well. So overall, students did find that question the most difficult. The other things I was going to say about the whole thing was the major things, the take-home messages for us as teachers for our classrooms is the setup of the logical PMI situation, mathematical induction, vector notation and integration notation. I remember when I was first marking eons ago, I couldn't believe that we were letting vector notation go through that was not vector notation in the marking process. It should not go through in your tests. Same with integration notation. I don't believe you should write an integral sign without a dx, a dt, etc. followed. That should be part of your teaching process, our teaching process. What we've noticed now that we have graph sketching in the specialist maths course, we are, as Dennis mentioned, we are requiring, and Val mentioned, we're requiring exceptional labelling. Not exceptional, you just have to label it. Clearly identifying what graph is what. Don't mind people using different colours in their exam. And also what we did notice, and we've all mentioned it, is clearly setting out, for instance, that question that Val just went through with the distance. We're not going to give a mark for the square root of x dash squared plus y dash squared because that's a formula that they should know or is on their formula sheet. So clearly showing all their working so that they can show how clever they are, basically. Accuracy and noticing that word exact. They are really the major go-home messages that we can give you as markers of this exam, that they're the things that we see students losing marks for unnecessarily. So I didn't have anything more to... Oh, yeah. When they do sketch graphs, we are still seeing sketching, like charcoal and like little lines, little line, little line, little line. Okay, don't draw me a set of tangents. Could you just draw me the line? So, I got a laugh. So, yeah, the nice smooth lines. And therefore, pencil is such a nice thing for graphs, but I'm not going to take a mark off for that. We should. No, don't. We won't. So, anything else, Dennis or Val? No? Anybody want to ask any questions? How are we going? We're all right. Questions? Nope. Oh.
Does anyone think the paper was too difficult? Is there a feeling from the floor that this is above and beyond what should be reasonably expected, or does it maintain a standard?
Did we think that the last question was poorly answered because of time? Yeah. Was there a time issue that impacted on that last one?
It was hard to tell whether that was an issue or not. Because students have the whole booklet, we can't tell whether students are working from woe to go. And so that's tricky to tell. But I suspect that time did come into it a little bit.
I guess if it's blank, I'd probably assume that some didn't get to a phrase if they answered it incorrectly.
And in fact,
Possibly,
most kids
yeah.
showed their love of Pascal's triangle
Yeah.
by putting it down. They didn't use it correctly, but there might have been a few bare elements beforehand, but just about everyone
Yeah.
put it down.
What we're seeing, what we're seeing nowadays is that I don't know whether students are getting used to it, whether our teachers are getting used to grabbing the little bits of marks of a big question, so that the little show that's or something like that, that they know that they can just chunk it through. Yep, got that. I may not have got those 4, but I've got those 3. So we're seeing that is a better approach by students for sure. Yeah.
Just in response to Dennis's exact question, my feeling after doing this one myself was, you guys nailed it. I thought it was the difficulty was perfect. It was probably a press for time for the kids, but that's always going to happen with a short exam.
Yeah.
And compared to last year, which I personally thought was too hard, or the previous year, the 2020, I thought this one, you guys got it dead right. So
Yeah.
thank you for all your hard work. It's a really good.
Thank you. We'll tell the setters. Thank you.
Sorry, Deb, just again, after the exam, I spoke with one of my students. He said that he didn't see the question on page 4 as he was flicking through because he saw the blank page on the other side. And I'm just curious, were there many students that skipped the answer question without...
Where are you in book 2?
Book 2, yeah.
Oh.
Book 2.
Well, I mean, bad luck. I mean, I don't think that's. We did not notice that people were skipping that. But what we do make sure that we have is that in a question that goes over to a next page that is not seen, so it doesn't open up to it, we sometimes will write this question blah blah continues on page blah.
As if it's shorter.
Okay, so that's, hey?
You mean if it's shorter?
Yeah, if it's shorter on, so if it's shorter on, if the question went to there and then blank, but there was more over the page, we would write question 7 continues on page 12. But one of the first things students should do, and I would be advising my students to do this, is to flick through the whole exam, making sure that they see the page numbers, making sure that they see everything on every page, and then they can't go wrong apart from their maths.